Hi there folks. In this video we're going to have a look at a Lee bullet mold, and this particular bullet mold is Lee's C312-185-1R mold, generally used for the 303 British and the 7.62x54R rounds. There are other applications of course, but those are the two most common rounds that you'll use this bullet mold for. And as the name would imply, it is a 312 nominal diameter bullet, and it is a 185 grain weight, and we'll see how that works out with the wheel weight material that I'm using. This is a gas check style of mold with a couple of lube grooves. So this was ordered online. As you can see by the box, the post office wasn't terribly kind to it. I've taken the mold out of the box since we don't really need to have a look at the unboxing of something like that. It comes of course with the usual instructions, which you should have a look at if you're not familiar with using Lee molds. Here are the blocks themselves, and we still have the inspection sticker stuck on here as the usual warning to clean the mold and lubricate it before its first use. So who's our inspector this time? We have Shirley. Well, I've gotten molds from Shirley's inspection handiwork before. Let's hope these ones are let's hope Shirley was having a good day. Anyway, as usual, the Lee molds include the handles, which is a nice feature. You don't have to buy separate handles, and the blocks stay permanently attached to those handles. You can see there's a couple of kind of dowel pins that go through the aluminum mold blocks. And these are the new style of mold blocks that Lee's making now. You can see they have a rather distinctive profile. They appear to be a couple of aluminum extrusions which have been machined into mold blocks. And the mold information is engraved on the top of the mold blocks, which is nice. The old Lee molds had the catalog number or the part number on them, but it didn't actually describe the bullet. So this is much more useful to the end user. You can see 312-185, so it gives you the basic bullet information right there on the top of the mold blocks. The LH that's printed on the top of the blocks refers to the left-hand thread of this hold-down screw. So if you want to loosen it, you have to go the opposite direction to what you're used to. So we've got a steel sprue plate and aluminum mold blocks. You can see even the top surface of the blocks has this venting pattern machined onto it, which is kind of spiffy looking. And inside we've got our two cavities for the bullets. And on the one set of blocks we have some dowel pins, I guess you'd call them. And on the other side we have some bushings on the other side, and those are both steel, which have been inserted into the aluminum. So this is a much nicer setup than the older style of Lee blocks that had some angular mating surfaces that relied upon the geometry to keep the mold blocks straight. I like this system an awful lot better. It's a more conventional system, and you can see that these line up quite nicely. There's no discernible gap between the mold blocks when they're closed up. Of course, these are brand new blocks, so if they're not good now, they never will be. And we've got some machining on the inside of the blocks here to affect a vent pattern, so kind of a spiral sort of pattern on both of these blocks to give us our venting so that hopefully we get good fill out. So pretty good looking set of molds actually at first inspection. And after a casting session, I managed to get some bullets done up. I think I ended up with about 350 altogether by going by weight anyway. This is just a sample of them. And let's have a look at what the finished bullets look like. And these are once again cast of wheel weights. And I'm not going to claim that these are all perfect bullets, but they're quite usable in my opinion. And that's what an unsized and ungas checked and unlubricated bullet looks like. I've got a bunch of them done up here with gas checks. You can see the gas check crimped on the base, and these have been run through a Lyman lubicizer and lubed with some home brewed bullet lube. And I've run these through a 313 sizer die with the idea that I'll use them most likely in Mosin Nagants, and they might be a little touch small for most 303s, but they might be okay for some 303s. So let's have a look at the diameter of one of these things. So we'll just take a measurement on the biggest diameter there, and we're getting right about 313, and undoubtedly when we turn this around it'll change a little bit. So this bullet is, of course, it's advertised as being a 312, so 313 is certainly within the ballpark. There's 314 at one spot. One important measurement that a lot of people neglect is the diameter of the nose. This is a nose riding or bore riding style of bullet. The back of the bullet fills up the grooves of the barrel, and the front part is supposed to ride in the bore. So a lot of these styles of bullets tend to be a bit undersized for many barrels, and this one is right at 300, which probably won't be too bad in some Mosin Nagants, but it will be a little undersized in almost all 303s, because 303s are almost always 303 bore size. The groove size does vary a lot with 303s, but the bores do generally stick to that dimension of 303. So this is a bit undersized for most of your 303 rifles in the bore riding portion. And the problem with that is if the bullet doesn't fit the bore at the front, it can get a little bit cockeyed. Obviously I'm going to exaggerate that, but it gets a little bit twisted, and it's going to come out not spinning on its axis quite as well as it should. So anyway, this I think will be a better bullet for the 7.62-54 than perhaps the 303 British, although I'm sure I'll try it in some 303 British rifles as time goes on. But anyway, there's what the finished bullet looks like. And these are what are they, 188 grains with the gas check and the lube on them, give or take a little bit, of course. And anyway, got some decent production going there. One of the slow parts to producing rifle bullets is running them through the lubicizer and putting the gas check on them. But that's just one of those things you do to get a bullet that's low cost in money, but it is high cost in time. So anyway, I can say that I'm pretty happy with this bullet mold so far. It works as advertised, and it's pretty close to the desired weight and the desired or specified weight and the specified diameter, so you're kind of getting what you pay for. And if you make a few hundred bullets with this and you never use it again, well, you've probably broken even, because with the price of jacketed bullets, it doesn't take many cast to pay a mold off pretty quickly. So this is my second example of this particular bullet mold. I had a single cavity which I used for quite a few years, and it was a good mold, but it of course, being a single cavity, it only dropped one at a time, which is a bit of a pain in the butt. So I took my single cavity mold to a gun show, and somebody gave me 20 bucks for it used, which was pretty good. So when I got home from the gun show, I ordered a new one for I think this was like 32 bucks, something like that. So twice as many bullets per hour, I guess, which is not a bad exchange for the extra little bit of money. Anyway, all that remains now is to finish sorting these bullets out, getting the ones with the wrinkles set aside, and throwing the really bad ones back in the lead pot, and doing all the gas checks and the lubricating and the sizing and all that stuff. And then I'll have, hopefully when I'm finished culling them, I'll probably have about 300 bullets altogether for my casting session. I didn't really keep track of how long it took me, but it's one of those things when I start casting bullets, I generally keep at it till I get, kind of disgusted with the process or bored too much, and then I stop. And hopefully by the time that happens, I have 200, 300, 400 bullets made up. Anyway, thanks for watching, guys, and we'll talk to you later.